In this question, it is mentioned that there are two beakers. In one beaker, there is a glucose solution, aqueous solution of glucose. In second one beaker, there is aqueous solution of urea. Aqueous solution of urea is filled, and both beakers are enclosed in a vessel. That is a vessel. Now actually that is beaker A and that one beaker B, and the mass of glucose solution is that is 196.2 gram, and mass of urea solution is also given, that is 152.4 gram is given. The urea solution is in beaker A and glucose solution is in beaker B, and the mass of urea and mass of glucose is also given. So mass of urea is given, that is 12 gram, and mass of glucose in glucose solution is also given. So glucose is 18 gram. Now we have to find out mass percentage of glucose in its solution at equilibrium. So what happened after some time, because there is mole fraction of glucose solution, mole fraction of glucose means X glucose is not equal to mole fraction of urea. They are not equal. It means one solution is diluted and second one solution is concentrated. Obviously the solution which is diluted means which has less quantity of solute, its vapor pressure is more. Vapor pressure will be more because when we add solid solute in a solvent, then its vapor pressure is decreased. So the solution which have less quantity of solute, that have more vapor pressure, and the solution which have higher number of mole or mole fraction of solute means concentrated solute that have low vapor pressure. Now what happened, after some time water vapors will go from the solution which have higher vapor pressure to the solution which have lower vapor pressure. So some number of moles of water will transfer from the solution which have higher vapor pressure towards the solution which have lower vapor pressure, and this process will continue till the equilibrium will reach, and at equilibrium mole fraction of glucose and mole fraction of urea will be similar. Obviously there will be decrease or increase of water molecule. That's why at equilibrium mass percent of glucose in its solution will be changed, and we have to find out the mass percent of glucose at equilibrium. So first of all we have to calculate which solution have higher mole fraction. So let's start. Mole fraction of glucose in glucose solution, it will be equal to N glucose divided by N glucose plus N water. N are the number of mole. Now N glucose means number of mole of glucose we can calculate Mass of glucose is 12. Mass of glucose, that is 18 gram. Mass of glucose, that is 18 gram. 18 gram is given, and molecular weight of glucose, that is 180. So these are the number of moles of glucose, that will be equal to 0.1. Again, number of mole of glucose, that are 0.1 plus mole fraction of water. So we have to calculate mass of water in glucose solution. The total mass of solution is 196.2, and mass of glucose means mass of solute is 18 grams. So we can calculate here mass of water. So mass of water in glucose solution will be equal to 196.2 means mass of solution minus mass of solute means 18. So that will come 178.2. 178.2, that will be the mass of water. So number of mole of water we can calculate by using 178.2 divided by molecular weight of water, that is 18. So when we calculate it, it will come 0.01. So actually that is mole fraction of glucose in glucose solution. Similarly, we have to calculate mole fraction of urea in urea solution. So mole fraction of urea we can calculate like number of mole of urea divided by number of mole of urea plus number of mole of water. Similarly, mass of urea is given, that is 12 gram, and molecular weight of urea is 60. So 12 by 60 divided by 12 by 60 plus number of mole of water. So mass of water we can calculate in urea solution. In urea solution, mass of water will be equal to, because the total mass of solution is 152.4 and mass of urea solute is 12. So solution 152.4 minus solute 12. So mass of solvent or mass of water we will get, that will be equal to 140.4 gram. So that is actually mass of water in urea solution. So it's 140.4 divided by molecular weight of water, that is 18. So hence we can calculate the mole fraction of urea. If we calculate it, they will come 0.025. So we can observe mole fraction of glucose and mole fraction of urea. So we can say mole fraction of glucose is lesser than mole fraction of urea. So that's why, because so vapor pressure of glucose is higher than the vapor pressure of urea. Vapor pressure of urea solution. So glucose solution vapor pressure is higher than the vapor pressure of urea solution. That's why some water molecule will transfer from glucose solution to urea solution till the mole fraction of both in both solution will be equal. Then equilibrium will come. So at equilibrium we can say, at equilibrium, what happen at equilibrium, suppose we let n mole of water, let n mole of water are transferred from glucose solution to aqueous solution of urea at equilibrium. So at equilibrium, let n mole of water transfer from glucose solution to urea solution. So amount of water in glucose solution will be decreased and amount of water in urea solution will be increased. So at equilibrium, mole fraction of urea in urea solution, mole fraction of urea in urea solution, that will be urea solution, that will be equal to mole fraction of glucose in glucose solution. So at equilibrium, mole fraction of glucose in glucose solution will be 0.1 divided by 0.1, that is the mole of glucose, plus 9.9, that are the moles of water. But because n mole of water we have, let na n mole, suppose n mole of water are transferred from glucose solution to urea solution, that's why we have to subtract here n. And mole fraction of urea in urea solution, that will be equal to number of mole of urea, that will be 0.2 divided by mole of urea 0.2 plus mole of water that was previously present 7.8, but plus extra mole of water n that comes from glucose solution. Now we can calculate the value of n. N means number of mole of water which was transferred from glucose solution to urea solution at equilibrium. So n we can calculate, and when we calculate n, that n is equal to 4. So what are n? N actually number of H2O water moles which transfer from glucose solution to urea solution. Now mass of glucose solution we can calculate. Mass of glucose solution. Mass of glucose solution we can calculate. That is mass, previous mass of glucose solution 196.2 minus mole of glucose that was transferred from glucose solution to urea solution, because these mole, 4 mole of glucose, 4 mole of water was transferred from glucose to urea solution, that's why we have to subtract it. 4 multiplied by 18, that much of mass was actually gone to urea solution. So answer will be equal to 124.2 gram. So at equilibrium, the mass of glucose solution is 124.2 gram. Now we can calculate percent weight by weight. Percent weight by weight means mass of solute, that is mass of glucose present at equilibrium, that is 18 gram. Mass of solution at equilibrium 124.2 gram multiplied by 100. So that will be equal to 14.49 gram. So that is actually our final answer, 14.49 gram. So 14.49 gram means answer B is correct answer. Thank you.